electrons will be emitted from the metal surface, no matter the intensity of the light or the duration the light is shone. Okay? The intensity / brightness of the light source is a measure of the number of photons. So it doesn't matter that there's more photons. If one photon doesn't have enough energy to emit the one electron, it doesn't matter how many you hit. Okay? So for example, a very intense light source means that many photons are being emitted. Therefore, if the photons from the light source have a frequency equal or greater than threshold, the current, so a current, remember, is a measure of the number of electrons, so current is the amount emitted, will increase as the intensity of the light source increases, if the photons are able to. Because it will be like, if those photons are able to emit the electrons and you hit more at them, then more electrons should be bouncing off. So think 1 photon per 1 electron. If the photons from the light source have a frequency equal to or greater than the threshold frequency, the kinetic energy of the emitted electrons will increase as the frequency / energy of light increases, and vice versa. So these two connections here we use to help us make our formulas. So therefore, the photoelectric effect can be explained using the conservation of energy. Because it's like saying, if all of that energy that's from the photons goes toward the energy of the electrons being emitted, they should equal if there's no loss of energy from any place. So what principal number is this? 5 indeed. So we're using the conservation of energy principle to make these calculations. So look on your atomic physics or quantum mechanics, as quantum mechanics is what we're doing. Is this equation there? No, because it's an equation based on a principle. Okay, so you have to apply a physics principle to make this equation. So if you are doing a multiple choice question or something and it's going to say which, and you had to use that calculation, if it said what principle did you have to use, you would say number 5. Okay, so any time where you have a calculation that you just knew how to do it because of physics, it's because you use these principles if it's not an actual formula. Okay, so this is saying all of the incident light, so that's the light coming in, that's the photons, the photon energy. So this is the energy of 1 photon is equal to the kinetic energy of the electrons leaving plus the work function, or the work done. So the work function is the minimum amount of energy required to release it. So the energy needed to give it that shove, and then how much energy it has while it keeps going. Okay, so the shoving and the momentum, or the energy it has when it's left. Shouldn't use the word momentum, the energy.
So the work is before it hits the plate?
Pardon?
So the work is before it hits the plate?
Or when it hits the plate, it's that work that's being done when the photon hits the electron.
Oh.
Yeah, think about it. Think about you pushing a box. you have to be touching it to do the work on it, then how much energy does the box have after you've pushed it? Yeah. Okay. Therefore, the work function and the threshold frequency are related to each other using this equation. W is equal to H times FO. Now, this one is found under atomic physics. Okay, so you can see W is equal to H times FO, where H is our Planck's constant. Depending on your units, you'll either use either your joules per second, joules times seconds, or EV times seconds. And your work can either be written in EV or joules, and your FO is always in hertz. Okay?